Stone.
Hi, so my name is Matt. I'm the BGC Soil Mechanics Team Research Development and Quality Lead. I'm excited to introduce Nick Stone, who will be presenting our next topic. Nick holds both a bachelor and a master's degree in civil engineering from UC Davis. And he's a geotechnical engineer at BGC with experience in various geotechnical projects involving soil mechanics, liquefaction assessment, and stability assessment. Recently, he's played a key role in guiding the development of BGC's new cone penetration test data processing, analysis, and presentation tool, which we call BGCPT. I'll pass it over to Nick to tell you more.
Hey, thanks for the introduction, Matt. I'm Nick Stone, and I'm going to present on BGCPT, which is BGC's internally developed CPT processing software, and how we're going to be using this to improve the quality of liquefaction assessments that we're completing. As an outline, I'll provide some context about the inefficiencies in how we're processing CPTs currently, and how BGCPT might address those inefficiencies. We'll talk about how we're continuing to develop the tool, some user documentation for the software, and provide a pretty brief project share where we've used BGCPT to process CPT data. So the BGCPT project was undertaken to improve the efficiency and consistency in CPT processing that we're doing, so that we're able to focus on the interpretation and not just more tedious processing of the data. So the previous workflow for processing CPT data would be to select an individual CPT raw data file, plug that data into a CPT processing tool, be it CPT plot, CPT, or CLIC, take the results from those different tools and output them into an Excel format, and then read that Excel format into a grapher template to produce report quality figures. And then you would have to repeat this process for every single CPT data file that you have, which would become fairly tedious and time consuming if you have, say, 20 CPTs, or if you're lucky enough to have a site with maybe hundreds of CPTs. So just focusing on one of these tools, which BGC commonly uses for liquefaction assessments, CPT plot. CPT plot is an Excel-based Visual Basic code for processing CPT data. The creator of CPT plot, Mike Jeffries, has stated himself that CPT plot has reached the capacity or practical limitations of VBA in Excel. VBA it's an older language with limited functionalities, hasn't been updated for many years. The code is tied to individual data sheets or spreadsheets, so that any change you might make to that code for an individual CPT data file, you would then have to copy paste and carry forward that change to all of your spreadsheets for all of your CPT data. And so moving this to Python, which is a more modern, intuitive language to use, it's one of the fairly popular, more common languages used today, has many powerful libraries for processing data, and is being updated continuously. So the current workflow implementing BGCPT using Python, now rather than selecting an individual CPT data file, you select a directory that holds all of your raw CPT data. Python reads this with an Excel reader, uses calculation libraries, leveraging tools like Pandas libraries, which is very commonly used to do calculations, and then use a writer to write those data into a standard Excel templates. More grapher optimized Excel template if you wish to plot your data in a non-standard way using grapher, or standard output report figures that BGCPT can produce. So on a high level, BGCPT can batch process plot CPT data for static and seismic liquefaction using multiple methods and provide basic soil strength parameters. So the screenshot here is one of the report figures that BGCPT can generate, this one being specific to a static liquefaction assessment, plotting state parameter calculated using 3 different methods here. With previous methods, if we wanted to plot these 3 state parameter calculations, we'd likely have to use multiple tools, But with BGCPT, we're able to have these 3 different calculations done in one place. And so the benefit of developing this tool internally at BGC is that as new literature is being published and the field is advancing, we're able to implement new calculation methods into the code as a project might see specific. If a client has a particular request for a certain calculation that they might want to see in their report, we can internally add that to our calculations and incorporate it into figures, rather than having to go externally to some tool, modify that tool, or request the tool to be changed. And similarly, as we distribute this tool to projects and they use it, if bugs do arise, they can easily contact us and like walk next door, contact me, say, hey, we have a bug with this problem, with this code. And then given priorities and project deadlines, we can quickly address those changes. As we continue to develop the tool, we're using GitLab for version controlling and tracking changes between multiple developers. So the screenshot showing GitLab below shows lines in red where we've deleted code and lines in green where we're adding code. So we're just keeping a history of all the changes that we're making to the code in order to maintain a sense of quality of any changes that are being made before anything is implemented and given to users for the program. Any changes to the Python code have to be approved by both an engineer and a data scientist. But if you're a user using this code, you're not going to be looking at the Python side of things. BGCPT is a very easy to use tool. It's an executable. You double click it on your desktop and it runs the data for you. But if you want to know what is happening in the back end and you have questions about what calculations are being performed, the Python code creates this comprehensive documentation, which is in an HTML format, so it's very easy to navigate. So below, you can see definitions of terms in blue here. If I wanted to know where effective vertical stress is being calculated, I could click this hyperlink. It would show me how it's being calculated, where it's being calculated, and then where it's used further down the line in the code. And then generating this documentation within the Python code is beneficial because as we're developing the code and making changes, it means it's less likely to become outdated. And so just as a pretty brief project share of how we've used BGCPT, a client requested that we provide static liquefied strength ratios of 2 tailings materials so that they could inform the inundation area size for a dam breach study. And they asked for this strength estimate on what would be, say, a pretty optimistic timeline if we were to use old calculation methods. But given we had batch processing capability with BGCPT, we were able to quickly process 66 CPTs that they had available to us and provide liquefied strength ratio calculation using the Robertson 2021 method, which is shown on the left here. And then because of the very convenient Excel output format that BGCPT has, we were able to quickly comment on some spatial trends of the data. So on the bottom right here is showing Robertson 2016 soil behavior type classification charts. And we're able to note that from zones A, B, and C, which indicate from A to C, increasing distance from the discharge location for the tailings, we're seeing a general trend of being above the contractive dilative boundary, which is this diagonal curving line here, to farther away. Largely the data is becoming below the contractive dilative boundary, so becoming more contractive. And this could qualitatively inform what materials are potentially more susceptible to liquefaction rather than just providing strength ratios. And it should be noted that this was not for a full liquefaction assessment. This was a relatively narrow scope, but we were able to provide a little extra context to the client here. And so this is just one project that we've used BGCPT. There's been a few other projects as well. We're still using the tool, even though it's being continually developed. So if you have any more questions about this, you can feel free to reach out to myself or Andrea Lougheed. Just want to acknowledge that I didn't do all this work. This was quite a lot of work between different participants at BGC. So yeah, Thanks. Happy to answer any questions.
Just checking to see if we have anything in the Q&A here or the chat, and folks are also very welcome to raise their hands if there's any questions for Nick. Okay, I think we're at the end of a really long day. It's not even been a full day, but there is probably folks whose brains are getting very, very tired. So if you do have more questions for Nick, then we will absolutely post his email in the chat. You can see it there as well. And I'm sure he'd be really keen to answer any additional questions that he might have. Over to you, Gemma.